Hello, welcome again to our topical solution series for IGCSE at Maths 0606. In this video, we're going to look at the topic on permutations and combinations. And the questions you're going to solve in this video is taken from May-June 2019, paper 2-1. Okay, before we go to the solution, let us take a quick tour, a quick revision over this topic. Well, overall, out of this topic, we only easily have three main tools to go about for all different type of scenario of conditions. Well, out of these three tools, we call them factorial, permutation, and combination. And for each of them, you can see this key in your calculator, x factorial, and in your calculator, you also can see NPR and CR. Well, now to make your learning more easier, I'm going to divide this tree into two different group. The factorial in one group, permutation and combination in one group. Why is it so? Factorial is uniquely different from the other two friends because factorial is the condition when for each time when you make a certain type of arrangement, no matter what number of choices that you are given, you have the liberty to display all of them all at one time. And that's what I mentioned here. All can be displayed each time. And you have no limitation, neither are you being restricted. For example, if you were given 8 pictures to be hung on the wall, you are not limited such as that out of these 8 pictures, only 5 you can choose each time to decorate the wall. No, for the occasion when you have all freedom and liberty, you are given 8 pictures and all the 8 you can freely arrange them and display all the 8 at one time. That condition, you will go for 8 factorial. Okay, so that's what we say x factorial, because x represents the number of choices that you have, and you have no restriction. All the whatever x number, you can display all the x all at one time. Now we come to combination and permutation. They are not that lucky as factorial. Permutation and combination, they face certain kind of limitation. For example, they are given n number of choices. For example, n is 8. Okay, that's what we had just now. N is 8. But out of the 8, you do not have the liberty to pick all the 8. No, out of the 8 choices, you can only pick R number of item each time. For example, if R equals 3, that means out of the 8 choices, each time you can only take 3 at one time. That's called limited choices. Okay, so now, how do we differentiate between permutation and combination? As stated here, permutation is when order matters, when order of the item makes a difference. Okay, and combination is when order doesn't matter. In other words, let's say if you put in 1, 2, 3, and then if the 1 is put at the back and 2 to the front, you got 2, 3, 1. It makes no difference from 1 to 3. That's what it meant by order does not matter. Okay, but for permutation, 1, 2, 3 is considered one distinct unique arrangement. If you put in 2, 3, 1, it's considered another combination. So that's why usually permutation is used when you have to calculate numbers of ways to form a passcode, security numbers, or the different sets of committee member can be drawn and established from a certain number of candidates. Well, that is the overall and a quick tour, a quick revision on this topic. With this knowledge, let's go on and deal with this question. Okay, let's read the question. This is from question 9. Part A. 11 different television sets are to be displayed in a line in a large shop. Here you go. Well, do you notice that they say 11 different televisions? Now, to be displayed in a line, they did not specifically mention that in that line you can have to display only 7 television. No, they did not say. So you are in the high possibility to use factorial. Okay, now let's read section 1. Find the number of different ways the television can be arranged. And that confirm your choice of factorial as your tool to calculate the total number of ways is absolutely correct. From 11 different televisions, you are not limited at any point of time to choose any television. No, but on the contrary, out of the 7 different televisions, you have the liberty to display all the 11 different television all at one time. Therefore, the number of ways you can arrange them is 11 factorial. With a few punch of the calculator, it will surely display for you 39,916,800 ways. Quite a lot of ways you can display your 11 different televisions. Okay, now let's proceed. Of these television sets, 6 are made by company A, 5 are made by company B. Okay, from the reading of the sentence, I organize them into company A, 6 model, and company B got 5 of them. Okay, let's read section 2 and see carefully what do they ask, and is there any restriction or any certain conditions they want to arrange the televisions. Find the number of different ways the television can be arranged so that, be careful, that's the condition, so that no 2 sets made by company A are next to each other. Okay, what does that tell you? They just simply tell you when they say that none of the 2 sets made by A are next to each other. They also mean that the television made by company A and the television of company B must be alternating each other. Okay, now we put in a little thinking. Let's list it down in this manner. Okay, if I were to propose the first arrangement, when we start with television from company A and alternating them to 11 television, 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, with the starting of the line with company A television, alternately accordingly all the way. Okay? And then we can also consider, could it be possible, can we go for the arrangement number 2, where we start with television from company B and we do the alternating accordingly with 11 televisions, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now, once you have that thought, let's go deeper to find out, does it work or not. For arrangement number 1, let's work out how many television A will that take up. You will notice 1, 2, 3, 4, 5, 6. In order to make this arrangement, you will need 6 television from company A. Do you have enough available to choose from? Yes, affirmatively. Now, in order to keep this arrangement, how many television of company B do you require? Let's count them. 1, 2, 3, 4, 5. You require 5 television from company B. Then, do you have enough? Yes, most certainly you have enough. So arrangement 1 seems to work. Let's consider over arrangement number 2. When you start with B, how many B do you need? 1, 2, 3, 4, 5, 6. For this arrangement, you will require to have 6 television from company B. Looking at the availability of television from company B, you note that, you do not have enough choice from the television of company B. Therefore, this arrangement has to be discarded because it doesn't work. All right? Okay, even though if we were to consider how many television of A, 1, 2, 3, 4, 5, yes, you have more than enough, but sadly, you do not have enough television of company B to make the arrangement of the second arrangement work. Therefore, you rule out this possibility because not enough of the company B television, so it doesn't work. Therefore, we're going to rule out this. Then from here, what we're going to know is we're going to follow the arrangement of the first one. Well, the six television from company A, let me put it down for us. Yes, this is from the 6 factorial of all the television of company A, and then the 5 factorial is the juggling around of the 5 television of company B, and with the puncher calculator again, it concludes for you the correct answer that you have 86,400 ways. Well done. Let's move on to part B. Okay, this time we no longer deal with television, but let's read the question. A group of people is to be selected from 5 women and 3 men. Okay, so what you're going to do is we're going to figure out which 2 are we going to use. All right, let's read the question first. Is the order matter or is the order does not matter? Part 1, calculate the number of different groups of 4 people that have exactly 3 women. Okay, now you want from the choices of the 5 women and 3 men, now you just have to pick 4. You cannot pick all the 8 of them. Too bad. From the 8, you can only allow to pick 4. And not only so, a condition was imposed upon your choices. From the four people, you are supposed to make it exactly 3 women. Okay, so now here is your condition. You need to make it exactly 3 women, and that total women that you have, that means from 5 women, you're going to choose 3 from the 5. And that the remaining 1 place, in order to make up 4 people, yes, naturally, you only left 1 vacancy available for the men to fill in. Therefore, what you have now is for the women, you will have from 5 women, you're going to choose 3. Whereas from the men category, from 3 men, you're going to choose 1 and only vacancy that's available for the men. Therefore, putting in accordingly, from the women category, you have 5C3, and she's noticed that we use a multiplication for the notations for n. For the men, you have from 3, you're going to choose the 1 and only vacancy to be filled in by them. So therefore, again, with the assistance from the calculator, you will have fully confident getting the full mark that you will have altogether 30 ways to choose different groups of 4 people each time, and out of these 4 people, exactly 3 women is in that. Okay, so that concludes part B1. Let's move on to part B2. Calculate the number of different group of at most 4 people where the number of women is the same as the number of men. Okay, that sounds really interesting. You still require to choose 4 people at one time with the condition that the number of women is the same as the number of men. So put on your thinking cap. What are the possible ways or options can you choose to make that? Well, they say at most. What do you get from that? At most 4 people. In other words, they say that maximum number of people you are allowed to choose is 4 at most, right? And do they allow you to choose less than 4? Most certainly yes, because they say at most 4. As long as you don't exceed 4, you are still fulfilling their condition. Therefore, with a little thinking, then we come about the option. First option, if we put in 1 woman, and 1 man, well, you fulfill the condition of the number of women is the same as the number of men, isn't it? And you also, at the same time, fulfill the limitation of not exceeding 4 people. You're in good shape. But not stopping there, do a little bit of cracking of your mind. Do you have other options? If you have 1, 1. Now, can you have 2 women and 2 men? Check it out. Yes, the number of women and men are still the same. How about the total? Yes, you fulfill the condition of at most 4 people, because you have a group of exactly 4 people. There you go. This is acceptable option for option 2, where you have two women and 2 men. How about 3 women, 3 men? If you were to do that, you fulfill the same number of men and same number of women, but you defy the condition that they set at most 4 people. Because if you go for 3 plus 3, you have total 6, which has exceeded the number of people that they limit for you, maximum 4 people. Therefore, we do not consider 3 women, 3 men. Okay, now with all the thinking has been done, there comes the easy part of it. So for the women, for this option 1, the one that I highlight with this beige color or yellow color, whatever you call that, okay, so you have, for women, you have 5 altogether, and men you have 3. Therefore, from 5 women, you choose 1. Got it? And with a multiplication for men category, from 3 men, you choose 1. Got it? Okay. And punch a little bit of your calculator, you're going to get 15 ways to form that. Then for your option 2, for the women category, from 5 women, you're going to pick 2. There you go. And for the men category, from 3 men, you pick 2 men. And with a little punching or keying of the calculator, again, for option 2, you can have 30 different ways of grouping. Now, you come to the final part, you put together the total ways that meet both of these conditions, at most 4 people. Second condition, the number of women is the same as number of men. Therefore, you take the 15, add up to the 30, you get for yourself 45 ways. And that's it for this question. Okay, if you have carefully run through this, wow, you'll be super encouraged. Quite a great encouragement and quite an awesome job has been done. Okay, so that's all we have for your learning in this video. Okay, we're going to say goodbye, and that before we end the video, as usual, it is my sincere wish to you and everyone to have happy learning always, and looking forward to see you again in the next video. Bye-bye.